All right, folks, let's go ahead and get started. Good morning, good afternoon, and good evening, depending on where you're joining us from in the world today. Welcome to this month's IDMS webcast. Before I hand you off to the team for the presentations, I have to cover just a couple things with you. First, as always, if you have questions along the way, please put them in the questions box right under the GoToWebinar control panel. Only I can see those, but I will make sure that I read those at the end of the session, and we'll get through as many of those as we can during our time together today. If we run out of time or if something requires a little extra research, I will make sure that the team has everything they need to follow up with you later. We are recording today's session. That's why your lines are all muted. The replay will be available, I'll probably post it out in the IDMS community either later today or first thing tomorrow. So if you want to share it with colleagues or watch some part of it again, I will also put the presentation out there as well. And the last thing for me is we want to make sure these sessions are as valuable as possible. So with that in mind, I've pulled together a short feedback survey. If you could give us an extra minute or so of your time at the end, it will pop up. We would love to get your feedback. That's it for me. So I'm going to hand you off to Sheila. So kick us off. Go ahead, Sheila.
Fantastic. Thank you, Len, and thanks to everyone for joining us today. We certainly appreciate your time and consideration. My name is Sheila Miller. I'm an offering manager here for our database products at Broadcom. We're excited to have several guest speakers today from the Smart Restart product team. We have Ison, Araba, and Kevin, who will be walking us through an overview of the Smart Restart product capabilities and the overall benefits, along with a brief demo of the functionality. So as part of today's session, we certainly do encourage questions, and we're looking forward to hearing your feedback based on our discussion through some polls that we have and also the survey that Lynn mentioned just a moment ago. So with that, I'll turn it over to Ison, and I'll be back towards the end of our session just to share a few brief announcements. So over to you, Ison.
Okay, thank you, Sheila. Hello, everyone. I'm Ison Svoboda, and I'm product owner for Smart Restart. And first, the disclaimer. Today, what we share with you is only informational, and there's nothing commitment. The information we share is valid for today. And to start with, let's first look into the business challenge we would like to point with our tool Smart Restart. Actually, I'm pretty sure you are much more familiar to this business challenge. You are living with them. And now many organizations, they need operations 24/7. Batch windows are reduced. Avoiding outage is critical. And in a problem case, recovering from the failure as quick as possible without losing too much time with minimum impact is crucial. Another topic is mostly batch and online transactions are together, and batch jobs restart after failing. It is one issue, but batch jobs might fail due to online transactions, and online workload might be failing due to batch jobs. And mostly the environments are data sharing, and in data sharing environment, and they need to access to the same data checkpoint, and concurrency is required. Backing up batch updates in a shared environment might be quite problematic. So what is the Smart Restart, the tool we want to introduce you today? It is a comprehensive ZOS batch application restart tool, offers support for various essential components like IDMS, DB2, IMS, MQ, WSAM, and sequential files. One of the key features is Sync Point Manager. This manager ensures that consistency is maintained across all components, even in the case batch job restarts. Smart Restart also offers automatic restart of batch jobs. If a job fails, the tool can automatically restart it, ensuring that the operation continues seamlessly. Another important feature of Smart Restart is automatic recovery and retry capability. This feature is especially useful in case of errors due to timeout, deadlock, or resource unavailable. And don't think that this is a new tool that we didn't verify. It has been successfully implemented in global 1,000 organizations worldwide. So it is a trusted tool. So in this drawing, we see how Smart Restart works. Smart Restart utilizes checkpoints to ensure reliable and efficient batch job execution. In the diagram on the top side, we see how batch job is progressing over time. With Smart Restart enabled, the job takes regular checkpoints and records its progress. In the event of failure, Smart Restart resumes the execution from the last successful checkpoint. This means that all the work completed until that successful checkpoint will be remained. And I want to underline that these checkpoints are not the execution steps in JCL. They are the data. So it's not like just removing some step from a JCL and submitting again. And on the lower part of the diagram, you see how it would run without Smart Restart. So you will submit a batch job who took error, and it would do all the work from the beginning. So what are the key features of Smart Restart? Firstly, batch is restartable on any member of the data sharing group. This means that if one member fails, the batch job can be restarted automatically in another member. Secondly, batch can be paused or canceled at a unit of work boundaries. This means when a problem is detected, batch can be paused or canceled at a point where no data has been corrupted, ensuring the rest of the operation can proceed without any issues. Thirdly, Smart Restart allows you to predefine different checkpoint frequencies for separate shifts, giving you greater flexibility. This is like, for example, during night, you might taking checkpoint less often, but during daytime, there is higher online transaction load, so you might be taking more often checkpoints. And moreover, this frequency of the checkpoints is can be set dynamically. So during the operation, it can change. Also, Smart Restarts can estimate the approximate end time of the batch job. And if somebody is going unexpectedly, it can pop up some warning that like this job will last longer than expected. Another important feature is the ability to edit program working storage, repair bad data during execution, and it is crucial in preventing data corruption and ensuring that operations can continue without any issues. Updates to IDMS, DB2, MQ, IMS, and other RS complaint resources remain in sync with sequential file and cursor position. Program storage, random, some updates. So if we go back to the business challenge earlier we talked about, so 24/7 availability, continuous operation is important, and with Smart Restart, you can handle the problems with batch jobs as quick as possible. It doesn't need some external human to interfere with the issue, and this helps you to save time, because until somebody is informed that that batch job received error and they will connect and understand the problem. Smart restart will just handle itself, retry if it is a problem like I talked earlier. If some resource is unavailable, it will just try once again. And also, it eliminates the possibility of human error. And I believe any of you has already experienced, like if you change some JCL and try to run it, most often you receive some JSL error, and JSL error is the best case scenario. At least it doesn't damage the data. So it eliminates the human error here. And in the scenario of there's a disaster recovery is also much more quicker than you will have without smart restart. In batch and online concurrency environments, it would arrange like if the number of online transactions are high and they are getting error due to batch job, it knows to like hold this batch job some longer. And if batch job is getting error because of online transactions, it does like it tries to access the resource, and if it is in use, it holds, waits for a while, and tries once again. And all these like hold on time and retry time, these can be set by you. Then it improves the concurrence and availability in data sharing environment. As we stated earlier, actually, if there is rolling back of the chains in data sharing environments might be quite problematic. And it enables restart of legacy applications without commit logic via external checkpoint definitions. And actually, to use Smart Restart, you don't need to change your source code. So altogether, it reduces the cost of the machine because you don't need to execute the same change from the beginning of the batch job. And people, you don't need so much operational activities from people, and it helps you to keep in the SLA agreements. For whom Smart Restart will be most useful? If you have a critical business, if it is important in terms of time, if you have jobs that running long hours and they might be streams, hard to restart complex applications or job streams. And if you have shared environments and they are sharing the data and object with other applications, and if you have online transactions and batch jobs together, it might help you. And at this point, actually, I want to add something more. We love to talk about business perspective, but when I look into the Smart Restart, before my product owner role, I was admin, DBA, and system programmer for different database systems, and I worked with 724 on calls, and I don't know how much time and how many nights I spent trying to solve the problems with bad jobs and all those domino effects. One job receives error during night, and then in the morning still some bad jobs are has some delay. So for me, I had to sacrifice for my personal life a lot. So I can't stop talking or thinking about the perspective, the value it would bring any mainframe person, not only the business itself. This is how Smart Restart architecture is. On the upper side, we see the type of methods that batch application can be controlled and restart enabled. In the middle, the blue line, it represents the smart restart. And at the bottom, we see what type of systems it is supporting with some DB2, MQ, IDMS, IMS, and sequential files. I will not too much spend time in this technical details, but if you would like to know more, we are open to explain you more about how Smart Restart works. This is a smart monitor, so you might be wondering how I will manage Smart Restart. We have Smart Monitor. It runs as an ISPF dialog. It monitors the active job steps. So here you can see a summary which displays restartable jobs related to the interval. So we are looking into one interval. We can see job name, job number, its status, and if it is completed successful or not. And there is ID and frequency. This frequency shows like Smart Restart is checking checkpoint. So for example, this 5 means like every 5 logical checkpoints, there is one physical checkpoint. And for the third line on the very right, you can see it is 100. It means that for every 100 logical checkpoint, Smart Restart is taking one physical checkpoint. So now Smart Restart is supporting IDMS with DB2. So it needs DB2 ZOS as a repository. But if you don't have DB2 ZOS, don't think that like it is not for us, because now we are working on removing the need for DB2 as a repository. However, to continue, we would like to know if you are interested in it, so that we spend our time, you put effort, something useful for you. Okay, so if you have already Smart Restart, if you have already IDMS and DB2, we can work with you. We can provide you temporary license. We can install in your environment, and you can test it. We can do such POC. And if you don't have DB2, we would like to hear from you if you are interested in it. So at this point, I would like to ask one question. Do you think Smart Restart will be beneficial to your organization?
All right, thanks, Dyson. Just give me 1 second. I need to actually post the poll out into the group.
Okay.
There we go. I've launched it. Always takes a few seconds to get out, and then we'll give folks a few seconds to actually answer it. Excuse me. Looks like people are just starting to vote now, so we'll let's say another 20 seconds or so. All right, looks like the voting has slowed, so we'll go ahead and close that one.
Okay, so thank you for your replies. And I have one more question. We would like to extend an invitation for a follow-up discussion with our team to explore the wide range of benefits of Smart Restart. Would you like to work with us? Would you consider to join us with this work? Like if you don't have DB2, if you only have IDMS, or if you have both, it is valid for both conditions.
And
right.
This is Rabbi Vigar speaking. I'm the product manager for Smart Restart working with ICE, and I would like to emphasize that basically you taking the time to sit with us would be very beneficial for us, in that we'll understand how you may leverage Smart Restart, and hopefully you'll get out with something from it, in that we can help demo and explore the full potential of Smart Restart and how it can be used within your organization. So this can be a casual discussion about how Smart Restart can be applied in your environment. If you have any questions, we can answer that. We're going to bring our SMEs to the session. So if you opt in for this one, there is going to be benefit there for both of us, hopefully.
Thanks, Rabah. All right, looks like people are still voting, so we'll do another 5 or 10 seconds. All right, thank you very much, everybody.
Okay, so now I will leave screen to Kevin. Kevin will make a demo for us.
Great, let me hand the ball off. There you go, Kevin. All right, we see your screen, you're good to go.
Okay, thank you. So what I'm going to do is show you a little bit about this application program that I'm using as an example here. And I'll show you a little bit about the JCL to run it. And then we'll actually run it, and I'll show you a little bit about the output, sort of try to understand what it did and how it came about achieving a successful result. So I have a program that is a test program. It's also
Oh, hey Kevin, I think you may have accidentally muted yourself.
Oh, I was talking.
You're back. You're back.
I'm sorry.
That's okay.
Okay, so I'm going to show a demo program that's really a test program and an IVP that we ship with sample JCL. I'll just show you a little bit about the program, a little bit about the JCL to build it and run it. And then we'll actually run it, and I'll show you a little bit about the output so you can see how it handled the failure and achieved a successful result. This program is this ID1 program right here. Let me get my focus in. All right, so the idea here is that you have a typical application program without any consideration for other products or whatnot. And so what's the minimal amount of activity that you need to make it eligible to be restart enabled, as we say it, so that if it has a problem, it's capable of being restarted from the last checkpoint. And by the way, when we mention the word checkpoint, we're really talking about the combination of everything that's involved in the application at a sync point. So when you do a commit, you set a sync point for the things that are in your database, in your DBMS, but you also have other things like maybe sequential files or vSim files, program storage, sequential output. All those things kind of need to be in sync, and so we help automate that process, get everything in sync, and then we call the net result a checkpoint. This is an example of an IDMS program that's just an IDMS program. It doesn't know anything at all about DB2. This is an example that uses a test database that's actually part of the install for IDMS. It's a series of objects in the database that are for a fictional company. And what I'm going to do today is work with one table out of it, which is the employee table. It's a list of all the employees, and we'll read it and update some status and that sort of thing. All right, there's no, as I mentioned, there's no concept really of DB2 in this thing, or even SQL for that matter. So just to show you, there's a comment here saying there's no SQL, and if I repeat fine, there's none. So nothing to do with DB2. What we normally would like to see is taking account of the three major things that have to happen that are relatively easy to set up. One is the working storage that you wish to be restored when a restart occurs. In other words, it's saved as part of the checkpointing process. And if we do a restart, the last checkpoint would include the storage that was identified here. And what we do in Smart Restart is we just have this one line that indicates the beginning of working storage that should be saved, and there's another one just very similar that indicates the end of working storage to be saved. This will automatically be inserted by the precompiler that we have, which I'll show in just a moment. But if you want to, and you probably should, review what kind of working storage you're talking about, what kind of storage needs to be restored and what doesn't, and then you can minimize the resources that are required for a checkpoint. And you can also make sure we don't accidentally do something like restore storage that has no relevance in the current environment. And I'll show an example of that. So I'm scrolling down. We get to the end. This is the end of the working storage that I've identified for this test program. There's some more things after this, and in particular, there's some IDMS structures, subschema structures that are embedded. Either you manually code them here, like I have commented out, or you use the IDMS precompiler, which will insert them. There are things in there that include like pointers to storage that might not be the same across the initial run and a restart run. So that's an example of things that you don't want to be in here, which is why the end of savable working storage is set like that. And then just quickly talking about the actual program, it's set up here where we have all of the things that are being changed in a unit of work concept, and there's a lot of discussion in our manuals about unit of works and the relevance and importance of actual sync points so that you take commits at the appropriate time. This test program has several different functions. We're going to use the update all one. It's right here. And you can see really that it's just going to go through a loop through all of the employee identifiers, and it's going to update the status of each one. So it's a pretty simple program. I want to show you just real quick the unit of work for this guy. And let's see, that is update one. Yeah. So he comes through and just figures out what he's doing and what status you want to set, and he sets it. And the important point here is that when you're finished with the update process, he does an IDMS commit, which tells all of the tasks to complete their work. This perform is just checking the return code. And then we're doing a commit via RRS. That's the ZOS Resource Recovery System. That's if you're not familiar with it, that's a feature. It's available in ZOS that allows you to do synchronization across multiple DBMSs at the same time. So for example, if you were doing things in DB2 and doing things in IDMS, and they all needed to work together, they were processing transactions that update both kinds of databases, then you want them all to be at a sync point at the same time, and RRS is a method for doing that. So while we support regular calls in DB2 and MQ and a number of things, we do not yet have built-in way to intercept calls into IDMS except via RRS. So that we're also using DB2 for our sync point management. So this is handy. It does both things at once. So when you make one of the commit call, you use RRS. It looks like this, and we will see those commit calls. Okay, so just moving on, I'm going to show you a little bit about the JCL. First, the build JCL, just briefly. You would do it more or less the same way you would for a normal IDMS application. You do an IDMS precompile. This will insert things like those schema definitions and whatnot in there. And then there's an extra step here where you run a Smart Restart precompile. You can do without the Smart Restart precompile if you manually enter the components that have to be there, which is simply a call for initializing Smart Restart, those storage boundaries that I mentioned, and then depending on how you exit your program, you can do a termination call. If you don't have a termination call, we'll automatically get control when the application returns to the system. Then you just compile it and you do a link edit like normal, and all of that's nothing special for us. And then we do have, because we're using DB2 for sync point control, we have a bind. and there's nothing to do with the program here, but we do deliver when Smart Restart is installed into a given DB2 DBRM that has the code that we execute in DB2 to manage the sync points. So it's all completely invisible to the application, but we do run and we create a plan with that package in it, and the application doesn't really have any concern with that, except for the fact that he tells Smart Restart which DB2 he's supposed to be using and what plan, which has that DBRM in it. So to run it, you run it just like you would run a regular program, and I'll notice you don't need TSO DSN run either, unless you prefer that. There's a connection management process that Smart Restart supports that makes this all very, very easy and automatic. We're using IDMS, so this is just simply how you tell them which database started task manager you want to use. They call it the central version. And it has to be enabled for RRS because that's the method that we're using to manage this. And then I've got a parameter here that just controls how the program works. And we're going to trigger a test tab in when we see this this employee ID 0321. That's just for this test purposes. So for Smart Restart, you can set up all the defaults to make it work like you want. You can also override any of those values at runtime by coding parameters in this RA input DE. And there's some basic stuff. I have messaging turned on at its highest level so that we can kind of see how it works and explain it how it works. This business about setting the system to point to a DB2 is only required because we're using DB2 for synchronization control. The plan that we just bound a minute ago, if you have a plan exit, sometimes people don't want to have to specify the plan and all that, and they just make up a plan exit that will automatically fill that part in. So the DB2 system name and the plan you're going to use can be automated so that if you're running thousands of batch jobs, you don't have to go and edit the JCL and all of them, that sort of thing. We're using RRS as our communication method, so we're just telling them that. And I'm going to skip down to a couple of interesting points here. Ison mentioned the whole business about logical versus physical checkpoints. And what we're talking about there is you get the most flexibility if you issue a commit every single time you complete a unit of work and find yourself at a sync point. However, if you're doing millions of transactions, you know, it's a lot of overhead on your database system to do that many commits. So what we support is this what we call pacing, and it basically says how often you want to take a commit, even though the applications are going to be doing a lot of them. And a real simple method is to just do it by count, but you can also do it by time. You know, if the rate at which you issue commits is somewhat variable, but you never want to be more than 10 minutes from the last commit point, then you can say, I want to take one every 10 minutes or 10 seconds or whatever is good for your particular application. And that's also something that can be changed on the fly. So if you find out it's taken a lot more commits than we thought, a lot faster than we thought, and there's a lot of database overhead going on, you can actually pause it with Smart Monitor, change this parameter, and then start it, resume it, and it'll pick up at the new rate. And basically, you didn't have to cancel and restart the job just to do these minor parameter changes. So with that, I am going to submit the job, and hopefully everything will run like it's supposed to here. This is not really a very long job, so it typically runs very fast, but we have a pretty busy system sometimes. All right, so what happened here happened very, very quickly. We're going to look at the output, but it hit that record that had that employee ID that I mentioned, the special one. And typical in COBOL, if you're working with a numeric field and you read in some transaction data and try to process that numeric field like an employee ID, and it turns out to have some characters in it that are not digits, then you'll get a SOC 7. So bad data is a common cause of these large batch transaction processors having a problem, and recovering from those is one of the special reasons that Smart Restart could be very helpful. What happened here is we had it coded, And I failed to mention that just a moment ago, so I'll touch on it again real quick. And it automatically retried this. And when it retried it, it pressed on with the rest of the transactions, and it finished with return code 0. So all we had is a failure that went. And back in that RA input, I forgot after checkpoint paste to mention this admin trap here. You can specify the kind of admins that you want to be able to recover from, and the R tells him to automatically retry them. The S says, I want you to go ahead and let the job terminate, and then somebody will review it and then manually resubmit it. But the point here is that it's ready to go unless you find some special circumstances. And if everything is good, all you have to do is resubmit it, and it'll just pick up right where it left off. It's set up to do that. That's why the automatic restart works well for these recoverable admin types. All right, so what I will do now is I will switch to the, it went too far. Pardon me. All right. So I am in SysView, and we're going to take a look at this program real quick. The first thing I will do, well, let me just look at the JCL at the front so I can show you what I was talking about a while ago. We have the program started and initialized smart restart, and these messages came out. After it finished with that, I'll show you this in more detail in just a moment. The application began to run, and then it hit an OC7. And on the system, once it started running, it was pretty fast. It only took it about a second to rip through about 30 odd updates, and we got the SOC 7. And then we recognized that as recoverable, and we set everything up to retry from the last checkpoint. We went through initialization again, restarted execution, and finished with return code 0. So looking at SRS print, this is the more detailed version of stuff that you don't have to produce. I just have the setup as be as verbose as possible so we can see it. During initialization, it repeats the parameter settings that you overrode. And then this is just a dump that I asked for of all the parameters that you possibly could change. There's quite a few of them. There's a fairly extensive reference manual. Most of these you don't have to worry about, but they're for special cases. If you run into a special case, there's a good chance we already have something to deal with that. When it finishes the initialization process, he will start up, and I'm going to get to there. There we go. A lot of messages that you don't normally have to produce. Restart, initialize successfully. He began to execute, and then we have him set up to dump out messages every time he takes a commit. And the interesting thing here is I set the pacing to 10, and sure enough, he did 10 commits in a row, or he did 9 commits without doing anything. He just passed. And then when he got to the 10th one, the 10th logical commit, he let that one pass through to IDMS, and it became a physical commit. And then he kept running. He got to number 20 and issued another one. He got to number 30 and issued another one. And then he hit the bad record and got an OC7. At that point, he recognized that it was recoverable and set up for a retry. And then he began to execute again. Well, let me get to the finish message where he's ready to start. Here's where he's saying the restart will be attempted from that checkpoint. And then he starts running again. So the restart's proceeding. And he begins to take process records and do more checkpoints. After the next 10, we do another one. And after the next 10, we do another one. And then the program finishes and returns, and we close it all out, do the final checkpoint. If the user didn't do one or we were pacing, then we do the final checkpoint at that point in time, and it terminates. So just to re-emphasize that from an application point of view, I had a number of displays in there, and this is the put out. These are just messages issued by the program, the test program, the function we asked for with the special admin parameter, and then he put out a message every time he updated and did a commit, and saying who it was that he committed and the return code. So here we can see all of these things coming through, And then we got to the one that caused the problem, and there was an OC7. It was recovered. We re-began. This one shows that he started with record 31, which means he fell back to the checkpoint at update number 30, which was our third actual checkpoint, and resumed with number 31 and pressed through until he finished. Ended up processing, looks like 56 employee records. One of them had a problem, so he ended up with 55 being actually processed and updated. So I know I kind of flew by that very, very quickly, but that's in a brief overview. That's kind of how it works and what it's all about, and a very simple example of how you can benefit from it. People that have problems with timeouts and deadlocks, that sort of thing, these can be automatically recovered and simply try it again. And you can put a limit on how many times you want to retry. You can say, with timeouts and deadlocks, wait a certain amount of time and try again. And if do that up to 3 times, and if it still keeps doing it, then let it fail, that sort of thing. And with that, I'll wrap it up.
Thanks, Kevin. Ison, I'm going to give you control back so you can share the rest of the presentation. And Sheila, if you want to come off of mute as well.
Excellent. Thank you, Len. Thank you, Kevin, Ison, and Raba for the insights. Much appreciated. And thanks again to our participants for providing feedback via the polls and the survey to follow. We look forward to engaging with you on Smart Restart. So if you could go to the next slide, if you don't mind, that would be great. Ison, if you can promote it, that would be fantastic. Excellent. Thank you. So we just wanted to take a moment to highlight the upcoming Broadcom mainframe technical exchange that we've been promoting. This will be in person, so that's fantastic. It'll be in Plano, Texas, June 13th to the 15th. For those who are unable to join our in-person conference next month, we are also hosting a virtual event in October 3rd to the 5th as well, so more to come on that. So those not familiar, I mean, this is really a fantastic networking event showcasing technical education, product updates, roundtable discussions, many product lines, including both IDMS and Datacom. We'll actually have our own track dedicated to the databases at the event. So if you can go to the next slide, I have a sampling here of a snapshot of what you can expect from an IDMS perspective. We'll get things kicked off with a couple of keynote sessions, followed by all kinds of IDMS product highlights, as you can see on the slide. We are also very excited to announce, if you go to the next slide, Ison, please, which is our IDMS pre-conference technical user group workshop and event night on that Monday, June 12th, just prior to the MTE kickoff, which is that Tuesday, the 13th. This will be hosted by our product teams in partnership with the IDMS User Association. So in addition to all of the valuable MTE sessions, these technical sessions are an opportunity to participate in educational deep dive product capabilities. So it'll be really interesting, and hope we can make it. There'll be transportation from the hotel provided along with food and refreshments throughout the day, followed by a dinner at the event night, which will be held at a place called Pinstack. We'll plan to have some fun there as well. I do want to mention, though, that the space is limited for both the event night and the workshop itself, and we are nearing capacity at this point. So if you haven't already registered, please take the time to do so if you're planning on joining us. The link is here on the slide, which will be provided to you as well after the session. And if you can just advance one more slide, Ison. These are the sessions that will be offered at the pre-conference on that Monday. Again, great insights on a variety of topics, as you can see here on the slide. So that's all goodness. And then finally, just a quick notification of the next slide, if you don't mind, that we've canceled our webcast on June 15th, as it's the same week as the MTE, so there won't be a webcast that week. And that pretty much wraps it up for the announcements. Just wanted to the quick call out on that. And so over to you, Len, with the Q&A stuff.
Thanks, Sheila. I don't see any questions in the questions box, folks. If you do have questions for any of our speakers, please feel free to put them right there in the questions box. And if you're typing something a little bit longer, feel free to just type wait and hit enter so that I don't close the session while you're still typing. We'll give it a few seconds to do that. And I will also remind you about our post-event survey. We'd love some feedback this morning. All right, I don't see anything coming in, so thank you very much to everyone for their time today. And I'm actually going to be traveling to Plano for MT as well, so hopefully I'll see a bunch of you there. Have a great time.
Thanks, everybody.
Bye, guys.
Thank you.